All right, so this is lesson 5.4. There's the homework. Here are the answers to last night's homework. You can pause and check. All right, today we are going to write a function rule. So far in this chapter, we've talked about domain and range, how to graph a function by hand, making an XY table, how to evaluate a function. And today we're going to learn how to write a function from a set of data. Okay. A function rule is an equation that shows you how variables relate to each other in a table of values such as an XY table. Some tables might use might use X and F of X instead of X and Y, but they're the same thing. That's called function notation. F of X means plug a value for X into the formula F. Think back to earlier this year. Yeah, I'm not 100% sure that this is accurate, but I want to say I remember doing this with you guys. Two things that we must find in a table to write a function. Do you remember? Coming back to you. Don't I have to find the change in X over the change in Y? I'm sorry, the change in Y over the change in X. So, we're going to write F of X equals change in Y over change in X plus what value went there? Remember? The initial amount. Starting out, initial amount starting out. So, what is my change in Y? We're adding 1, adding 1, adding 1. What's our change in X? Add 1, add 1, add 1. Now, this was the tricky part. Do we have the initial amount in this table? Where is the initial amount located? It is above, but what is the X value for the initial amount? Ashley, correct. Now, look how handy this is. Is 0 directly before 1? It absolutely is. So, what is the starting of that value going to be if I'm working backwards on that right side? 2. Because 2 plus 1 is 3. So, my function rule, change in Y over change in X is 1 over 1. Remember, delta Y over delta X means change in. And if you don't know that, you better write those words down. My change in Y is 1. My change in X is 1. So 1 over 1 is 1. So my function rule, F of X, is my change in Y over change in X, which is 1X, plus my starting amount, 2. There's my function rule. Now, of course, people, we did a little more investigating in this table. What do I do for 1 to get to 3? I add 2. What do I do for 2 to get to 4? I add 2. What do I do from 3 to 5? I add 2. So my function rule is X plus 2. You could have just figured that out. That's a super easy one, though. Not all rules are going to be that obvious. Let's take a look at this one. All right. Let's see what our pattern is. What's happening on this right side? What is my change in Y? Adding 1. And over here it is also adding 1. Do I have my initial amount? Do I have my initial amount? No, Miss Trizzy's being a jerk. I'm pointing to I am pointing to Y is 0. Is that the initial amount? No, the initial amount is when X is 0. what will the initial amount be? So, who thinks they can give us the function rule for that table? I'll start it out. F of x equals, what will the function rule, Justin, be? Because our change in y over change in x is 1 over 1, so 1x, which is just x. Original amount is negative 2, minus 2. Now, let's check and see if that function rule works. If x is 1, 1 minus 2 is negative 1. If x is 2, 2 minus 2 is 0. Yes, aren't we subtracting 2? Yeah. All right, let's look at this one. My change in y is what? Add 3, add 3, add 3, and over here, add 1, add 1, add 1. What's the initial amount in this table? What is the initial amount going to be? 1. Who can give me the function rule? Give me the function rule for this function. Let's see. Because this change in y over change in x is 3 over 1. That's the change in x or y over x. Your function rule, Lexi, looks like this. F of x equals your change in y over your change in x times x plus the initial amount. Okay? Now, let's see, guys, I highly recommend that you test your function rule. So, let's put 1 into this function. 3 times 1 is 3, plus 1 is 4. Yep. Put 2 in. 3 times 2 is 6, plus 1 is 7. Surely it works. And if I kept checking, it would work. All right. A carpenter buys finishing nails by the pound. Each pound of nails costs $1.19. Write a function rule relating the total cost C of x to the number of pounds of nails x. Who can give me the function rule for that situation? Give me the function rule. What are they? 119 pounds. This is not difficult. Yep, that's the change. The change is 119 per pound. Now, what's the starting value in this? Isn't it 0? 0 pounds, $0. So the starting amount is 0. So we don't have plus anything. Now, if we want to find the cost of 12 pounds, we'll do C of 12 is 119 times 12. What do we have there? 119 times 12 is $14.28. Okay. Suppose you borrow money from a relative to buy a lawn mower that costs $2.45. You charge $18 to mow a lawn. Write a function rule to describe your profit P of N as a function of the number of lawns mowed. So, you start out buying a lawnmower for $245 before you start your little summer job business, right? And you're going to charge your friends and family and neighbors $18 a yard, per yard, not a square yard, like an actual yard in front of your house to mow their lawn. Who can write a function rule, P of N, to describe your profit? Profit is how much money you make net. Okay, well, I agree with you, but we're going to use 18N because they told us N is the number of lawn. 18N minus 245. Is Justin right? Is he right? Yeah, because that 245 is money that you had going out in the beginning of the summer. So you start the summer in the hole because you got to pay for that lawnmower. So you got to make $245 just to get back to even, right? Now, that's it. Now, here we go. Challenge problem. Now, let me show you how you know that things have gone amiss. First of all the functions that we've dealt with so far are what we call linear functions, and you don't know that right now. You're going to learn about that in chapter 6. But when you write a function of the form change in y over change in x plus the initial value, that's linear. And all the ones that we've done so far are linear. So then we get to something like this, and you try to do the same thing. Okay? Let's look what happens here. Okay? So let's do our change in y. What are we doing to get from 1 to 9? We are adding 8. What are we doing to get from 9 to 16? We are adding 7. What are we doing? Oh, sure. Oh, okay. What are you doing from 16 to 36? We're adding 20. And then you go, what in the world is going on? Well, let's see. Maybe over here it'll sort itself out. What do we do from 1 to get to 3? We add 2. 3 to 4, we add 1. 4 to 6, we add 2. And now I go, what in the world? Is there a constant rate of change? No, there is not. Because 8 divided by 2 is 4. 7 divided by 1 is 7. Right there, you know, the rate of change is not going to be the same. Okay? Then, we go, well, even if I went back to the initial amount, I wouldn't know what to do over here because there's not a consistent pattern. So what we've been doing does not work at all. So then we have to look a little bit deeper. Okay? Now we look from x to f of x. This first one is not going to help me at all. 1 and 1 don't help you. 0 and 0 don't help you. Because you could do anything to get from there to there. Now, what are you doing to 3 to get 9? Oh, squaring it. What are you doing from 4 to get to 16? Squaring it. What are we doing from 6 to get to 36? Squaring it. So, what is my function? Oopsie. F of x equals what? X squared. X squared. Will that work? If x is 1, 1 squared is 1. If x is 3, 3 squared is 9. 4 squared is 16, blah, blah, blah. There we go. So we try to find a function the way we know how to do it. Finding the rate of change, which is the change in y over change in x, and then finding the initial amount, but it didn't work. So now we have to look deeper. All right, let's look at this one. Here we go. Over here, add 3, add 5, add 7. Well, at least that's a little bit better of a pattern than it was over there. Let's have, whoa, this looks better already. Add 1, add 1, add 1. Is the rate of change going to be the same? 3 over 1, 5 over 1? No, they're not the same. So I can't use change in y over change in x. We can't find our rate of change. But let's look from this side to this side. Well, let's look at the simple one. 1 plus 1 is 2. Is 2 plus 1 5? Think about it for a second. I'm going to pause this. Delaney came up with f of x is x squared plus 1. Does that work for every one of these numbers? 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. Yes. 3 squared is 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. Yes, it does work. So, if you cannot find a consistent pattern, and remember, our linear function, f of x, is our rate of change times x plus initial value. And our rate of change is change in y over change in x times x plus the initial value. If that does not work, then you need to start looking